Example number 2 also shows you a scatter plot, but they kind of scaffold the questions to ask you specific questions about the correlation between height and the number of steps. So looking at this in your head, you should be thinking, is this positive or negative? If you read it from left to right, you're seeing it's going down, so it's negative. It also has a moderate to strong correlation because those points are pretty close together. There's not a whole lot of variability and spread around. So the example says that the scatter plot shows the height in inches and number of steps needed for a random sample of 36 students to walk the length of a school hallway. The correlation is R equals negative 0.632. Explain why it isn't correct to say that the correlation is negative 0.632 steps per inch. So remember that correlation does not have a unit. Rather, it tells you the strength and direction of the association. So this negative 0.632 does not have a unit, so you cannot say it's steps per inch. That's a unit. We can't have a unit when we're talking about correlation. Part B says, what would happen to the correlation if the number of steps was used as the explanatory variable and height was the response variable? Nothing. The correlation would stay the same. Remember, we said that we could switch those and nothing's going to happen. A negative correlation means that as one goes up, the other goes down. So as height goes up, the number of steps go down, or as height goes down, the number of steps goes up. So with that opposite direction, it's always going to be negative. Lastly, part C says, what would happen to the correlation if height was measured in centimeters instead of inches? Again, nothing. We said that the unit does not matter and does not change. So the unit does not change the R value. Perfect. So again, correlation does not imply causation. So in some cases, there might be a cause and effect relationship, and we will learn how to distinguish cause and effect in the next unit. So in Unit 3, we'll talk about cause and effect, but just because two things are correlated or they have the same trend does not mean that one causes the other. So they ask us to interpret the scatter plot shown to the left. So we're going to use our sentence stem from the previous page. So you should have that out in front of you. And we are going to start with the correlation and they don't give you an R value. So because they don't give you an R value, you can estimate that the R value is going to be positive and strong. These close dots in the very close linear relationship is going to indicate a strong R value. So the correlation of the scatter plot below, or to the side of the scatter plot, indicates that the linear association between revenue from skiing and number of deaths from tingling is strong and positive, and that's a good enough interpretation because it's strong. All your points are close together on that positive linear slope, and that's why it's positive. The back of this worksheet or this packet goes through how you do all these calculations in the calculator, so I'm going to show you that, and then we'll practice more in class because I know some of you don't have the calculator at home. There is an app you can download on your phone that is identical to the TI-84, and so we'll download that app in class and use that a little bit so you can have the ability to answer some of these types of questions when you're not in class. Okay, So to do this on the calculator, I'm going to show you. It goes through step by step right here. We wanted to make sure you had that in your notes so that when you are doing it in class, you do have access to that. Our data is down here. So it says that a student wonders if tall women tend to date taller men than do short women. She measures herself, her dormitory roommate, and the women in the adjoining dorm rooms. Then she measures the next man each woman dates. Here are the data in heights of inches. So we have our women for X and our men for Y. And we're going to see if those heights are correlated. So to do this, we go Stat, Edit. We need to clear out our lists. We're going to put our X value in L1, our Y values in L2. But remember, it doesn't matter which one you do it because it doesn't matter what the explanatory variable is and the response variable is when calculating correlation. So for women, I'm going to do 66. 64, 66, 65, 70, 65, and in L2, 72, 68, 70, 68, 71, 65. Once you've plugged all of your data values in, you're going to go back to Stat, over to Calculate, and we are going to go down to Linear Regression, AX plus B. There are two different linear regressions, and you should get the same one either way. In the next packet, we'll use number 8, so I guess we should just use number 8 now. So number 8 is linear regression. Now, when you do this, and it only comes up with your A and your B value, it's because you didn't turn on the catalog in your calculator. So to do that, you go second, 0 to get to the catalog, and you have to turn your diagnostics on. So you're going to go all the way down to diagnostics. And as we prepare more for the AP test, I will remind you over and over and over, and Ms. Lucas will remind you over and over and over to turn your diagnostics on so that it's the first thing you do when you sit down and take the test. You don't have to worry about it. So I'm going to do the same thing, go down to number 8. Now that my diagnostics are on, I'm going to get a little bit more information. So my A value is going to be my y-intercept. My B value is going to be my slope. My r-squared value, don't worry about that for right now. But the r value is 0.565. So r equals, r being your correlation coefficient, 0.565. Great, we found the correlation coefficient, but something that a lot of you are forgetting to do is always this second part where it says explain or describe or interpret. So we need to interpret what this correlation means. So the correlation of r equals 0.565 indicates that the linear association between the heights of women and the heights of men they date is moderate and positive. So there is a moderate correlation, meaning that one can predict the other sometimes with moderate degree of certainty, and there is a positive. So as the height of women goes up, the height of men goes up, or as the height of women goes down, the height of men goes down. They follow the same trend. That's what positive correlation means. I hope you found this video helpful. You do have 5 homework questions on correlation, and we will do an activity on correlation, so make sure you get those done, and we will see you in class.